Our next topic is something that we've already kind of done, and this is just an application of derivatives. It's called optimization. Businesses, different people, anyone in any walk of life is always trying to optimize things. I want to do things so that I minimize the amount of time I spend on it. I maximize the amount of enjoyment. I minimize the amount of resources I use to do something. I maximize my profits. I minimize my cost. I maximize the efficiency of my workers. I minimize the downtime if I'm producing something. So it's all about minimums and maximums. That's what optimization is. Good thing we've just learned how to find minimums and maximums. Good, so we're ready to get down to business. The first thing you have to do is, for any situation, and these are going to be all reading problems, figure out a primary equation. If you're trying to maximize profits, you need an equation for profits. If you're trying to minimize the amount of surface area, you need a surface area equation. So find that primary equation. Step 2, is there more than one variable in use anywhere? Okay, so what I mean is, if you're finding the area of a circle, that only has one variable. The area on one side equals pi r squared on the other. There's a radius on the other side. If you did the area of a cylinder, then you have pi r squared h. There's two variables on one side. That's one too many. So what you'd have to do is come up with an auxiliary equation somehow relating the radius to the height. When you plug that back in, you'll have one variable on each side of the equation. You're good to go. Don't forget to pick out a reasonable domain. This is important. I'll show you in a minute, but it's good to know, is it possible to have a negative number for my situation? Is it possible to go beyond a certain value? Sometimes there's limits on how big or small your numbers can reasonably be in the real world. Hey, and then last, find the extrema. This is the thing that we've been practicing the most. So that's where you just take the derivative, find the critical numbers, and if you need to know what's a minimum or maximum, or you can't tell right away, go ahead and make a sign chart. That will tell you where it's increasing or decreasing and show you what the extrema are. Optimization is a fancy word for find the min or the maximum number. So here's an example question. You're trying to make boxes to ship something or package something, maybe to a grocery store, maybe somewhere else. There's an open top. You have 24 by 24 inch pieces of cardboard. Using a machine, you bend them up in a certain area, cut the corners, or at least cut part of it, and then glue them together to make a nice little open box. But you want to maximize the volume of this. So how do we optimize this? Using the same amount of materials, what size box do we create that will maximize the volume inside of it? So number one, start with the primary equation. What are we looking for? We're looking to maximize the volume of a box. Base times length times height. I'm going with base times length times height. Use width times length times height, or whatever it is that you like there. Okay? Whoa, way too many variables on the right-hand side. It seems like we should only have one variable over there, or so I'm getting that impression. So how could we rewrite this knowing it's 24 by 24 inches? We don't know the width and the height and the length of all of these sides here. Well, it just so happens that if we cut off a little square from each corner, or cut out a little square from each corner, we can call the length of that square x. What that helps us do is we realize that when we fold this up, the height of this box will be x. That also means that the base of my box, this portion right here, is going to be 24 minus 2x. And this length here for the length is also 24 minus 2x. I've used auxiliary equations, and now I can rewrite what I have. Substituting in here, I can easily find out an equation for my volume, and now there's only one variable there. What's the reasonable domain? Can my domain be bigger than 24 inches? Can it be less than 0? I think not. Taking the derivative, I find my critical values at 4 and 12. However, 12 is not a good number. Why?